All right, in this video, we're going to go through algebraic expressions and solving algebraic equations. All right, so let's talk about what a term is. So a term, say we have gt squared minus 2xt plus 2s. There is three terms here. Here's our first, then our second, and our third. Notice here in the first term, it's g times t squared. Then I have a subtraction. Addition and subtraction are what separates terms. And then my second term is 2xt, right? And that's all multiplication, so that's considered a term. And then I have my plus sign, so that separates that term from the last term. Right, and so when we are combining terms, we want to combine terms, that means we are either adding or subtracting. And you can only combine terms if one, you have same variable, and two, you have same exponent. In other words, you must have the same letter with the same powers to combine terms. And this is called an algebraic expression because there's no equal sign. So, if we have 5x squared minus 4y plus 2w minus 2x squared minus 3y minus w. If I look at my terms, I have 1, 2, 3, 4, 5, 6 terms is currently how this algebraic expression is written. Now, if I use the commutative property, I can rearrange these things, right? However, I have an issue. I have these parentheses. So to get rid of these parentheses, I will distribute this negative sign through, which is basically a -1, right? So this is why the properties we learned are so important, because now I have 5x squared minus 4y plus 2w minus 2x squared plus 3y plus w. Now, I can use the commutative property and rearrange these things and do 5x squared minus 2x squared, and then minus 4y plus 3y, and then plus 2w, not y, plus 2w plus w. And the reason I want to do this is because, remember, to combine terms, you have to have the same variable and the same power. And now that I have them grouped this way, it's easy to see them next to each other. You don't have to do this stuff. I think it makes it a little easier. Now, when I'm adding and subtracting terms, the variable and the exponent do not change, just the coefficient in front of them, the number. So 5x squared minus 2x squared becomes 3x squared. Negative 4y plus 3y becomes a -1y. And then 2w plus 1w becomes a 3w. Now, we typically don't write our ones in front of our letters, so the proper way to write this is 3x squared minus y plus 3w. And that is the final answer. So again, just to recap, adding and subtracting terms, or combining like terms as we call it, right? You have to apply the properties we learned. I use the distributive property to get rid of the groupings. I then use the commutative property to put like terms together, and then I combine my like terms by looking at the variable and the exponent. All right? Now, when I go to multiply terms, right? So we have 2a cubed b times a negative 6a b squared, right? There is no plus or minus, so this is considered one term. And all I'm going to do is distribute everything from the inside to the out. Well, I'm going to put like things together again. So I have a 2 and a negative 6. So I can rewrite this as 2 times a negative 6. Then I have an a cubed and an a inside the parentheses. And then I have a b on the outside and a b squared inside the parentheses. So again, I can use the commutative property of multiplication, right? I move things around and put things together. Now, we have to remember kind of our rules of exponents, which we will go into detail much later, but just a quick recap. Rules of exponents. If I have the same base, a to the m, and I'm multiplying it to the same base to a different power, I just add the powers. If I am same base and I'm dividing, I subtract the powers. If I have a power to a power, I multiply the powers. Anything to the 0 power is 1. Anything to the negative power is I flip it. And if anything has no power, 1 power, you just write the letter, right? So there's the quick rules of exponents. We will cover this much and more later in the course, but just to help us do these simple parts, I will realize, again, we're going to use this 1. When there is no power, there's a 1 there. When there is no power, there is a 1 there. And now I can use the rules of exponents to simplify this problem. So the first thing I do, 2 times negative 6 is negative 12. A cubed times a to the 1 becomes this first thing. I add them, so 3 plus 1 is 4, so that becomes a to the 4th. B1 to the b squared, again, I add them, so that becomes a b cubed. And so my final answer is negative 12, a to the 4th, b cubed. So there is a quick recap of our rules of exponents, as well as how to multiply terms. A lot of you have maybe seen foiling before, right? FOIL, which was first, outer, inner, last. So if I have something like x plus 2 quantity squared, that's the same as x plus 2 times x plus 2, right? And now if I have FOIL, first is the 2 first things. So x times x is x squared. Outer is the 2 outer terms. So x times 2 is a 2x. And then our inner are the 2 inner terms. So again, 2 times x is 2x. And then our last, which is yellow, is kind of hard to see, but there's our last. We multiply the last things. 2 times 2 is 4. And then while we have to learn how to combine terms, we look to see if there's anything in common. And in this case, we do have 2 things in common. So our final answer is x squared plus 4x plus 4. So FOIL is a little trick. Really, all you're doing is distributing. So if you've never used FOIL, that's fine. You're just distributing from everything from one grouping into the other, and then combining like terms. All right. Division, we can have 4ax squared minus 6a squared to the x all over 2ax, right? Well, when I have a single term in the denominator, a trick is I can break this into two two fractions. So 2ax minus 6a squared x all over 2ax, right? Because they have a common denominator, I can break it into two fractions. And now I have two terms, one term, two terms. And now I just use the rules of exponents, right? Rules of exponents say when I divide, I subtract the powers. Well, 4 divided by 2 is 2. A over a is just 1. I'll put it there. This is a placeholder for now. X squared over x, again, that has a 1 on it. So I subtract the powers. 2 minus 1 is 1, so that just becomes an x. Minus 6 divided by 2 is 3. A squared over a, subtract the powers, so I just have a. And then x over x become 1. And then I can simplify this down to be 2x minus 3a. So when you have a single term denominator, not so bad. Where it gets a little trickier is when you have a multiple term denominator, which we call a polynomial. So say we have ax cubed plus 4x squared plus 3 all over 4x squared minus 1. We can't break it apart. Well, we can. It's not mathematically wrong, but it doesn't help us any. So what we actually have to do is long division. So I do 4x squared minus 1 divided by 8x cubed plus 4x squared plus 3. Right? And now what I do is like these little rules over here, draw a dashed line. And I always make a joke of this, but I call this my scrap paper. And so what I do is the first step of my scrap paper is I take the first term of the numerator and I divide it by the first term of the denominator. So I have 8x cubed all over 4x squared, which gives me 2x, right? 8 divided by 4 is 2. X cubed divided by x squared, you subtract the powers, and I get an x. Then step 2, I take my answer from step 1, and I multiply it by my denominator. And that gives me 8x cubed minus 2x, right? Because 2 times 4 is 8, x times x squared is x cubed, 2x times a negative 1 is just a negative 2x. Now, you take step 1 and you write it up here. So there I put my 2x. I take step 2 and I write it below here, 8x cubed, and I'm going to put this guy over here because there is no x in the denominator. And then I must subtract the entire thing. So 8x cubed minus 8x cubed is 0. That is what we want to happen. And my little scrap paper piece over here is what guarantees that to happen for me. So my first term is canceled. Now I bring everything down. 4x squared minus nothing is 4x squared. There's nothing to subtract my 2x from, but a negative and a negative becomes a positive, so it becomes a positive 2x. And 3 minus nothing is a plus 3. Now I do the whole process again. Step 1, 4x squared divided by 4x squared equals 1. Right? So then step 2, 1 times 4x squared minus 1. Right? Now I rewrite up here, so I have a positive 1, so this becomes a plus 1. I write this below it, 4x squared minus 1. Again, I subtract, so I put everything in parentheses to remind me that I'm subtracting. 4x squared minus 4x squared is 0. 2x minus nothing is just 2x. 3 minus a negative 1 makes that a positive, so it becomes a plus 4. Come to my scrap paper again. 2x over 4x squared equals 1 over 2x. That is a rational number, so I stop. It doesn't go in evenly, so I stop. So my final answer is 2x plus 1. I had a remainder, so I do plus 2x plus 4 all over my original denominator of 4x squared minus 1. Not a pretty problem, I know that. Dividing polynomials is not well. We will get to this further in the course, and we'll get lots of practice, but this is kind of the worst way to do it until we get into some better algebra and we start understanding how algebra works, and we'll find other ways to solve these problems where they are not so bad. The good news is division always works. It might be ugly, but it always works. Okay, so that's all of those have been algebraic expressions. So I think what I want to do now is get into solving algebraic equations. And again, the big difference between an expression and an expression, no equal sign, an equation has an equal sign. So solving equations means solving for the letter or variable that you are looking for. So say we have 2, 5 minus x plus 3 equals x minus 8, right? So first thing I want to do is get rid of my groupings. So step 1, remove groupings. Right, and that means either distributing or using the associative property. So in this case, I am going to distribute the 2 through. So I will get 10 minus 2x plus 3 equals x minus 8. Then what I want to do is move things around. So get my variable that I'm solving for to one side. Variables to one side. So I have a negative 2x, and I'd like to keep things positive, so I am going to bring him over to join his friend by doing the inverse property. So minus 2x, so I'll add a 2x, add a 2x. So 10 plus 3 equals x plus 2x equals 3x minus 8. All right, now step 3, move all coefficients to one side. In other words, get all the numbers to the other side. So I will add an 8 to both sides. So now 10 plus 3 is 13, plus 8 is 21. So I get 21 equals 3x. And then I'm going to divide by 3 to get x by itself. And finally, x equals 7. So the little trick that helps you kind of keep things in line. If I am moving terms around, then I am going to be adding and subtracting. If I am trying to break terms apart, then I am going to multiply or divide, right? So multiplication and division is how I get my variable by itself. Now there is a step 4 that almost no one will do, but you should. Check your answer. I should be able to put 7 back into the equation and it works. And I'll kind of let you do that on your own if you would like. In the classroom, I kind of show that. But let's kind of, all right, so let's just do one more, just to make sure that we're a little comfortable with this, right? So what if we have, change my color here, 1/2 4w plus 6w equals w minus 3 all over 3. And now we got our lovely fractions that we don't care for here, right? Well, what I would recommend doing is, well, in this case, you could distribute because 1/2 goes into everything, but assume that it does not. Assume that it does not for a second, just so I can show you this trick. If I find a number that both 2 and 3 can go into, in this case is 6, right? And if I put this whole thing in brackets, I can multiply this entire thing by 6, right? All right, so by multiplying it by 6, or at least common multiple that we learned earlier, then I can get rid of the fractions. You don't have to do this. You can keep everything in fraction form, but I like to do this because it makes it a little easier to work with. So I'm going to multiply everything by 6. So 6 times 1/2, right, is 3. So this becomes 3, 4w plus 6w equals, then 6 times 3 is 2, so that becomes a 2w minus 3. Now all of the fractions are gone, and I can solve it. Again, there's lots of ways to solve these. This is just a trick. Now this trick only works if you have an equal sign. If you do not have an equal sign, then you cannot do this trick. So this will not work on expressions. This will only work on equal signs because I am not changing the value of the variable I'm looking for. I am just increasing it, and then I will simplify it back down. So now I can apply the distributive property and distribute through. So 12w, oh, actually, all right, cancel that. I can actually do what's in the parentheses first. 4w plus 6w is 10w, so this becomes 3 and 10w equals, distribute this one, 2w minus 6. Multiply those two things, so 3 times 10w is 30w equals 2w minus 6. I subtract the 2w, and that gives me, I'm running out of room, so I'll write it over here. That gives me 28w. Right? And then I can, minus 6 equals a negative 6, sorry, not minus 6. Then I divide by 28. So w equals negative 6 over 28. Now I simplify it. They're both even. I divide it by 2, which gives me negative 3 over 14. So I do still end up getting back in fraction form, but I don't get to the fraction to the end. Now, could you have just multiplied everything by 1/2 and then found a common denominator? Of course. But what's interesting is when you found your common denominator for your fractions, your common denominator would have been a 6. Okay, I think that is good for kind of chapter 1 overview. So I will post this video and then we will continue on in the course. Email me if you have any questions.